Hi everyone, welcome back to Innoskrit. So let's solve today's LeetCode challenge, which is length of longest subarray with at most k frequency. So let's try to read the problem statement first. So we are given an integer array nums and an integer k. The frequency of each element x is the number of times it occurs in an array. An array is called good if the frequency of each element in this array is less than or equal to k. We need to return the length of longest good subarray of nums. A subarray is a contiguous non-empty sequence of elements within an array. So let's try to look at an example and try to understand it. So here we have this example. I have taken the example from the LeetCode editorial, right? So it's a very good example. Let's look at that. So we are given k as 2 for this example, and we need to return the largest subarray in which the frequency of each element should not exceed this k, right? That means, let's say if we have 4 different elements in this particular subarray, right? Let's say 4 different elements. So all of those 4 different elements should not exceed this in number, right? Like each element should repeat only at most twice, not more than that, right? So we need to return that particular length of this subarray. So as you can see in this particular example, so I think maybe this is an example. This is the length. Sorry, not 3. This would be the length 8. 1, 2, 3, 4, 5, 6, 7, 8. Right, 1, 2, 3, 4, 5, 6, 7, 8. Yes. So you can see that in this particular subarray, your each of the element is not repeating more than twice. Right. Let's suppose if there was 6 over here instead of 3. So we could have taken this 6 as well. So it's not mandatory that each of the element has to repeat twice. It is basically at most twice. It should not exceed twice. Like it should not exceed 2 in number, right? Great. So if the question is clear, let's try to look at the explanation for this, because it's very simple, and I hope like you know now how do we identify whether the problem is of sliding window or not, right? If not, I think you really need to go and watch some of the videos on sliding windows. So let's look at that quickly, how we can actually solve it, because it's very easy. So we will take a start, we will take end, like we always do in sliding window questions, right? Because this question is related to frequency, so we will have to make a frequency map as well. So let me make it quickly. Frequency map, right? I'll be storing frequencies in this particular map over here, right? And then what we will do, we will take one variable which is max length, right? Because we need to store max length at the end. Let's initialize it with 0. Now what we'll do, let's try to look at this. So this is the end variable. Okay, let's store this. Frequency is not exceeding 2, right? Because just don't forget k is 2, right? So frequency is not exceeding 2. Okay, we will simply take this and make it move forward. Okay, current element is, and yeah, like I will try to keep updating the length as well. So the length has become now 1. Let me just go back. So now the length has become 1. Okay, now make your endpoint move forward. Okay, so this will become 2, 1. The frequency is still not greater than 2. Increment the maximum length. Increment your end. Store the frequency. Your frequency is not exceeding, the current element is not exceeding 2. So increment the length. Increment your end. Frequency will become 2. Maximum length will become 4. Increment your end, maximum frequency will become 3. And now at this point in time, the frequency of your current end element is basically exceeding this 2. That means this window has now become invalid. And that is why we are not really updating our max length, right? So first we need to make sure that this window becomes a valid window. How we can actually make it valid? Until the frequency of this one is not actually stable. What do I mean by stable? Stable means that once again, if it doesn't become 2, we will keep on incrementing our start, right? So let's take this as start pointer and make sure that you decrement the frequency of this current element, this start. So this will make it 2 and your start will increment it. Now just check whether the current frequency of your current end element is now stabilized. Yes, the frequency of this one is now stabilized, which means we can actually now start incrementing our end. Let's increment end once again. The frequency will become 2. And now update the length, try to update the length, because last time the length was still 4, but now because end is incremented and we have added a new element and still the frequency is under constraint, that means we can actually increment our maximum length. We can update our maximum length, which is 5 now. Okay, great. Let's move further. Let me just remove it. Yeah. So now let's move further. 5. Now 5 is coming as a new element. 1. Still the frequency is under constraint, which means we can update the length. So length will become now 6. Great. Let's move forward. And so this will incremented. The current element frequency is still under constraint, which means we can again update our maximum length. So maximum length now will become end minus start plus 1 and maximum length. So it will become 7. 1, 2, 3, 4, 5, 6, 7. Yes. Great. Now let's increment this end once again. Now this end will become, so this current element will be added and it will make the frequency of 3 as 3. which is not under constraint, right? It is exceeding your k, which means now your current window is unstabilized. This is not stabilized anymore. This is invalid window, right? So what we have to do is we need to make sure that we keep on incrementing our start pointer until we make this particular current element stabilized, or you can say like we basically make it valid, right? So what we'll do, we will take this current element, which is 2, and we will make it move out of the window, right? So when this will go out of the window, the frequency of 2 will become 1 and this will be incremented, right? And now you can see still your current element frequency is not valid window, right? Is not valid frequency, right? So we will again take this start pointer and make this 3 out of the window, right? So when this 3 will go out of the window, so this will become actually 2, right? So the frequency of this 3 will become 2 and your start will be incremented, and once again we will check whether this 3 frequency is now become valid, right? So it is valid now, which means you can try to update your current length. So current length is actually 6, but your maximum length is already 7, so this will not be updated, and now we can move forward. So this end will move forward, and now your current end is basically 1, so we will increment the frequency, and now you can see that in your current window 1 is appearing 3 times, which is invalid, right? The current element frequency is 3, which is greater than 2, which means we need to again make it valid window. So what we'll do to make it valid, we will make this 1 out of the window. So when this 1 will go out of the window, this will become 2 and this start will be incremented. Now you will once again check whether the 1's frequency is now valid. Yes, it's valid, which means you can actually try to update your maximum length, but maximum length is still 6, and like the current window length is 6, but the maximum length is 7, so this will not be updated. But now you can move forward, take the next element, and which will again make the frequency of this one as 3, and now once again you can see that this is invalid, so we will take this 1 out of the window, and then this will become once again 2 and start will be incremented now. But you will again check whether this 1's frequency has become now valid. Yes, it's valid now. So what you can do, you can try to update the length, but the window length is still 6, but the maximum length is still 7. So you will now move forward. End is now at 2, and you can again increment the frequency, but the frequency is under constraint, which means you can move forward and try to update the length. So the current window length is basically 7. Your maximum length is also 7. So the length will not be updated, but you can move now forward. So now 5 is coming. So we will make it move, we will make it increment by 1. And now you can see that your current frequency is still under constraint. The 5's frequency is still under constraint. And now you can actually try to update your length. So when you will try to calculate the current window length, which is end minus start plus 1, this will become 8. And this 8 is greater than 7. So you will update it, right? Great. Now you will move forward. And now this will become 3. Your current window, current frequency is now invalid frequency. So you will have to make it valid. So you can actually make it valid by making this 2 out of the window, right? So when this will go out of the window, your start will be incremented. And now your current window has become stabilized. Now once again, you can actually calculate the length, but the length is still 8. So it will not be updated. But yes, you can move forward. And when you will move forward, you will come to 3. So 3 will become 3. The frequency is invalid, which means you need to make this 5 out of the window. So when this 5 will go out of the window, it will become 1 and this will be incremented. But your current element frequency is still 3. That means you need to still make this 3 out of the window. So you will decrement this, and now this start will be incremented. Now once this is stabilized, you will once again calculate the length, but the length is now 7, but you have already maximum, you have maximum length as 8, so this will not be updated. Now you will move forward, and when you will move forward, you are out of the you are out of the bound, right? Your array will end over here, and you will be having your maximum length in your max length variable, and now you can actually return it, right? So I hope you have got this. We are basically iterating each element twice, not more than that, right? So the time complexity for this solution is big of n, and because we might store all of the elements, like in the worst case scenario, all of the elements can be unique, so we might end up storing all the elements in the hash map. So this is why the space complexity will also be big of n, right? So I hope you have understood this problem statement. Let's try to code it quickly. So what I'll do, I'll basically take a map of integer comma integer, and I will take a few variables like start, which will point to 0, and max length, which will also point to 0, because initially the length will be 0. And now I can simply run a loop, and now I can fetch the current element. So current element will be nums of end, right? And I will try to store it in my frequency map. So I'm simply incrementing the frequency of the current element. Now I'll make sure okay, now what I can do is I will basically increment my length. So max length will become math.max of max length and current window length. So current window length can be calculated by this, right? But I'll make sure that I will only increment my length, I will only update my length once my window is valid window, right? Otherwise I cannot do that. So to make sure that my current window is valid, I can run a loop while this frequency of my current element is greater than k, right, I'll keep on shrinking my window, right? I'll keep on shrinking my window. And how can I shrink my window? So I will calculate the left element, which is nothing but nums of start, right? And I will make sure that I will decrement the frequency of this, right? Because this is moving out of the window. So I can say, okay, just make sure that you get the left frequency and making it -1, right? And you will increment your start plus equal to 1. That's it. So once this is stabilized, once this window will become valid, once the frequency of my current element is actually lesser than or equal to k, right? So then I can actually go and increment my, or you can say like update my maximum length. Otherwise, until and unless this frequency is greater than k, I will keep on shrinking my window, right? And let's try to run this. Oops, sorry, this is get. We are in Java, so we will make it get. Yeah, and now let's try to run this. Oh, we are missing returning statement. So return max length. And now let's try to run this once again. Yeah, and let's submit this. So yeah, this got submitted. So I hope you have understood this. So this is it from my side for this video. I will see you in the next video. Till then, bye bye.